I've decided to start this course by introducing earthquakes and their implications and why they happen. It may be a strange place to start a course in geology. Usually you may think of geology as starting with rocks and minerals or the foundational materials that make up the planet. But if you think about it, by understanding earthquakes, it provides an entree to understanding many of the other phenomena that take place on the planet. Have you ever felt an earthquake? Many of you may have had that opportunity. It really depends on where you live. Many of you may never have felt an earthquake. Maybe you felt just a small tremor. Maybe you felt a major earthquake. But if you think about it, what does it actually represent? Start with a small tremor, a little bit of ground shaking. An earthquake can be just a vibration of the Earth's surface that shakes you, shakes the dishes in your cabinet, shakes the leaves in the trees, shakes the surface of the water around you. Or it can be a huge jolt that suddenly throws everything up into the air, causes buildings to crack and topple, causes dams to break, can cause all sorts of phenomena that are just catastrophic to society. Both of those are examples of earthquakes, but they have a point in common. And that point in common is that both of them are simply vibrations that are affecting the surface of the Earth. So really, to understand what an earthquake is, we have to understand what a vibration is. What is a vibration? Well, you're familiar with vibrations if you've ever thrown a pebble in a pond or you've ever snapped a stick. I happen to have a stick here, so I'll take one and I'm going to break it. It's obviously coherent, nothing up my sleeve. You can hear it cracking, you can hear it snapping. Suddenly it broke. Now when it snapped, two things happened. First of all, you heard it. And that's because the break of the stick generated energy that caused the air in front of the stick to vibrate back and forth, and that energy was transmitted to your ears, caused your eardrums to vibrate back and forth, and you heard it as a vibration. I also, though I can't really show it, I felt it in my hands. If I did it in slow motion, I'll take this bigger piece here, that stick went back and forth like that, and I felt it as a bit of a shock in my hand. That's a vibration. Now, an earthquake is really very similar to that. It can be the transmission of energy from a place where something breaks, in the case of the Earth, rock. The earthquake vibration goes to the surface and causes the surface to vibrate, and therefore generates ground shaking and creates either the small tremor, if it's a small earthquake, or the huge jolts, if it's a giant earthquake. We talked about vibrations as being generated by the breaking of a stick. You can also think about vibrations as being generated by a pebble striking the surface of a pond. So imagine that this is the surface of the pond. Drop a pebble over here. That pebble pushes down on the surface of the water, and then as it sinks below the surface, the water at the surface of the pond springs back up, and then it settles back down, springs back up, and it damps itself out until finally it's not moving anymore at the point. But that energy doesn't just stay where the pebble strikes, it starts to migrate. In other words, it creates a series of waves, the manifestation of the vibration on the surface of the water, that move outward from the point of impact until they reach some other location. It's just the vibration that's going up and down. And when it finally gets to this rubber ducky, it caused the rubber ducky to go up and down. So the point is that vibrations provide a means to transmit energy from one location to another location. They provide means to transmit energy from where a pebble strikes the surface of a pond to where the duck is floating in it. And likewise, they provide a means to transmit energy from where rock breaks in the subsurface to the surface of the Earth nearby or in some distance to create an earthquake.